All right, so now that we have that mole concept and we understand how to come up with a molar mass for a substance, we can finally do problems like this one on the slide currently. So what we're actually going to be doing is a process that's actually called stoichiometry, which is a really weird word. But I can do these stoichiometric calculations, which essentially tell you, given an amount of a reactant, how much of a product can be formed, right? And vice versa, how much of a product you're going to make, how much of a reactant it would take to make that thing. But this these calculations are not really hard. You just have to figure out the process, right? It's going to be the same thing every time. So if you just get used to how it works and you show your work, right, you should be able to do this pretty easily, right? Now I could make this hard, but I'm probably going to ask you it the same way every time on the test. So it should be pretty easy to follow along with an example and just do the same thing to get your answer. So our problems are going to look something like this. If 99.8 grams of sodium bicarbonate is heated, how many grams of sodium carbonate will be produced? So I have these two things in a reaction up here, sodium bicarbonate and sodium carbonate, and they're related to each other, right? When I heat the sodium bicarbonate, I make sodium carbonate. I also make water. I make carbon dioxide. But this balanced equation is essentially telling me for every two sodium bicarbonates, I'm going to make one sodium carbonate. And I'm going to use that. But remember when I was talking about that aspirin reaction a long time ago when I was introducing that mole concept, I could talk about two molecules of something being related to one molecule of another, right? And then I took that a little bit further. I could talk about 6.022 times 10 to the 23rd molecules of one thing and then relate it to that exact same number of molecules of another. But I can't really just compare masses across the board because different substances have different molar masses. So that 2-to-1 ratio that's going to be useful for me won't be useful unless I have a mole amount. So this process has more than one step. You just need to learn what steps to do, how to do it, and it should be pretty easy. So I'm always going to start with grams. And the first step of the process is going to be to change grams into moles, right? And in order to do that, I'm going to need molar masses, right? I have 99.8 grams of sodium bicarbonate. And I'm going to need to find out how many grams of sodium carbonate are produced. But before I can relate those things, I need to change the 99.8 grams into moles. So again, to figure out a molar mass for something, I need to know what all these pieces added up are equal to. Right? So I have multiple atoms there. I just have to add up the parts. Sodium is 22.99, hydrogen 1.01, carbon's 12.01, and then I have 3/16 to add into that. So once I add up all those pieces on my calculator, I find out that 1 mole of that substance is equal to 84.01 grams. So I'm going to use this number and I'm going to use my 99.8 to figure out how many moles of that substance I really have. So I start out with 99.8 grams in my railroad tracks, and I'm going to divide by 84.01 grams to give me an answer in moles, because 1 mole is equal to 84.01 grams. So I should be able to cancel out grams here. I get a mole answer, right? But that's not the last step in the process, right? The next step of the process is actually to relate 1 mole to another mole, right? So I have moles effectively of A that I need to turn into moles of B, right? So I need to do a ratio at this point. right? I already know that for every 2 sodium bicarbonates, I'm going to make 1 sodium carbonate. So I just use that ratio, right? So I have a label here right now, sodium bicarbonate, and that's what I'm trying to switch up this time, right? Because for every 2 moles of that sodium bicarbonate, 1 mole of sodium carbonate is going to be produced. So I can use that ratio to change moles of one thing into moles of another. So now I have moles of sodium carbonate as an answer, right? But again, that's not really what I wanted for an answer. I wanted to know how many grams of that sodium carbonate will be produced. So there's one last step to the process, right? And that last step involves me using a molar mass again, but now it's sodium carbonate, so it's going to be different than that molar mass from before. So remember my 22.99 for sodium before, I need to double that, and then I need to add 12.01, and then I need to add 3 times 16 one more time. So it has a different mass, and it's a bigger mass, right? 1 mole of sodium carbonate has a mass of 105.99 grams. So I just added up the pieces on my periodic table again. But this time I need the moles to cancel and I want grams as an answer. So I need to put the 1 mole on the bottom because that gets rid of my mole label in my work. And put the 105.99 grams on the top. So now I should be able to multiply and divide in my work and come up with an appropriate answer. So everything's where it needs to be, all the labels canceled out appropriately. All I have to do is multiply and divide. So I take 99.8 and I'm going to multiply by 105.99. Then I'll divide by that 84.01. And I'll also divide by 2 because that's part of my ratio, right? I don't have to do anything with all those ones, so I should be good there. And my answer here that I should probably have 3 sig figs for because 99.8 was a measured value. Remember the 1 to 2 is actually a whole number ratio. That shouldn't have any sig figs for me to worry about. And the 1 moles are exactly 1 mole, so I don't worry about those either. But with 3 sig figs, my answer is going to be 62.9, well, excuse me, it was 62.9556, whatever on my calculator. I was looking ahead and not really paying attention. I'm going to have an answer of 63.0, right, because of the way that that rounds, grams, and it's grams of my sodium carbonate at this point. So I'll probably label that. Don't forget my 2 in my formula. So again, all of our problems in this, well, all the problems you have to do of this type are going to look similar to each other. So you just have to build off of and model off of what you've already seen.